Okay, today we're going to be factoring trinomials, which we've done before. But what we're going to do to make these different than what we've done before is we're going to put a number in front of our x squared term. Our lead coefficient is not going to be 1. So our typical factoring chart is not going to work on these problems. So what we want to do is we want to create a new factoring chart technique. The way of finding the correct pairs is going to be pretty much the same. But what we're going to do is we're going to transform the linear term into two separate terms to create a 4-term polynomial, which we will factor by grouping. Alright, so here's how we make the chart for this one. We want factors of one thing whose sum is another thing. So it's the same kind of looking chart that we initially factored trinomials with. We haven't really used the chart recently. We've been doing more guess and check with these, so I'd have to kind of go back to how to do the chart. But what we did before was I put a -2 here and a +1 there, right? That's how we did it before. When you get a lead coefficient, what you have to do is multiply these two together to get what goes here. So 6 times -2 makes -12. And I'm going to put x squared on that. Alright, so basically I'm just multiplying this whole term times this whole term to get what goes there. And then whatever this is goes right here. So +1x goes there. And I do recommend putting the 1 there just to reinforce there's a number in front of the x. My goal is to find the two numbers that multiply to make -12 and add to make -1. I'm going to put an x on each one of those things. So I think we can all figure that out. That's +4 and -3, right?
Yeah.
But I'm going to make 4x and -3x. I'm going to do it just like that. 4x minus 3x makes 1x. When you get the pairs, it shouldn't be that difficult to get the pair. I don't need you to list every single possibility. But if you can't think of it right off the top of your head, 1 times 12, 2 times 6, 3 times 4, just kind of work your way up until you find the correct pair. Alright, once you've established what the correct pair is, this pair of numbers is the magical pair that multiplies to make the correct product, adds to make the correct sum. That's what we're going to change this object into. Alright, so I'm going to make it like this. Got 6x squared. I'm going to go -3x plus 4x minus 2. I'm going to go that route. The other option would be, let me put a line here, I could have gone 6x squared plus 4x minus 3x minus 2. Okay, both of those mean the same thing, right? So -3x plus 4x makes x, 6x squared is still 6x squared. This makes the same as that, and -2 is still -2. And then 6x squared is 6x squared, 4x minus 3x is still plus 1x minus 2. So I haven't changed the overall problem, I've just changed what it looks like. All right? I'm going to tell you that this one's better than this one, and the reason why is we're going to factor by grouping. When you factor by grouping, you're going to group things together, pairs of things. So if I group here and I group here, what's in the middle of the groups is a plus sign. If I group here and group here, what's in the middle of the groups is a minus sign. Alright? Now, it's not impossible to do it this way, but keep in mind, this expression has to match that expression. If you take a look, 6x squared is still 6x squared, 4x minus 3x is still plus 1x, but now I've got minus 2, which is actually plus 2 instead of minus 2. So if there's a minus sign here, I'm going to make this a plus sign here to account for that. Minus a +2 makes a -2. Okay, you don't have to worry about that kind of stuff if you get a plus in the third position. But if you have a minus in the third position, you do have to do a change of the sign here. So, not that that's terribly difficult, but that's one extra thing to think about. So I personally would avoid this technique, but going over here, when you factor by grouping, it's all about taking out common factors. So 6 and 3 both divide by 3, x squared and x both divide by x, so 3x is a common factor. If I extract 3x from both terms there, I'm going to get 2x left from this one, minus 1 left from that one. The second group, common factor of 4x and 2 is 2. And if I take a 2 out of both terms, I'm left with 2x minus 1. And the factor by grouping technique works when the group here is the same as the group there. The factored form then will be 2x minus 1 times 3x plus 2. And there's your factor form. Had I gone with this one instead, common factor here is going to be 2x. If I take 2x out of this, 6 divided by 2 is 3, x squared divided by x is x, 4 divided by 2 is +2, x divided by x cancels, Second group, I've got a minus sign. Common factor there is no common factor, so I'm going to put a 1. And if I take a 1 out, everything stays as is, 3x plus 2. And you can see here 3x plus 2 matches 3x plus 2. And 2x minus 1 was the common factor, so 2x minus 1 is going to... Same result, different order. But that's how you factor a trinomial with the lead coefficient for now. Okay. I say for now because when you get good at this, you'll be able to look at the problem and just write the answer. Just like currently you can look at the problem and write the right answer for x squared plus 5x plus 6, right? X plus 2x plus 3. Simple. All right, these become, they're more difficult, but if you do enough of them, you'll start looking for things. If you want to verify a solution, it's real simple. This product is supposed to equal this. 6x squared, outside and inside, 4x minus 3x makes positive 1x, last, negative 1 times 2 makes negative 2. If you FOIL it, you should get the correct result. If it doesn't make the correct result with the FOIL, that means your answer is not correct.